Hello, this is Gary Liu. Today I'm gonna give you three math puzzles that I want you to try. First one is this. What I want you to do is first I'll try to make six by adding any math symbol you want. However, the limit is that you cannot add another number. Like for example, you cannot square a number because you just added a little 2. You cannot cube root or fourth root it because you just added tiny 3s or 4s. And you can square root though. You can use any math symbol you want. Just don't add any numbers. Like, and yeah, you need to try doing them all from 1 to 9. Right. Let me do one of them for you. Like 2, 2, 2. Yeah, I think we all know what you know how to do this one. Just say 2 plus 2 plus 2, that's equal to 6. Simple, right? See if you can do the others. First. And I'll get back to you later. Okay, did you pause the video yet? If you haven't paused the video, I suggest you pause the video. I'm just sitting here because I don't think you paused the video. Well, not only do you need to do this, but you also need to try to figure these out while listening to me talk, which might be pretty hard. If you just pause the video, then you won't have to hear me talk. Okay, well, now you're gonna listen to me talk because I'm gonna give you the solutions to these. Okay, if you don't want to know the solutions yet, just pause the video. So, the next one, 3, 3, 3. Okay, this one you can just do 3 times 3 minus 3. Or just, you can do anything that will allow you to get 6. 6, but this is just the way I do it. 4, 4, 4. Yeah, you can just simply square root it, and now you have 2, 2, and 2, and just do something as you did earlier. So you get a square root of 4, that's 2. 2 plus 2 plus 2, that's equal to 6. 5, okay, just do 5. 5 divided by 5, that's equal to 1, right? 5 plus 1, that's equal to 6. 6. This one, yeah, there are many ways you can do this one. Like, you could do 6 times 6 divided by 6, or you can do 6 plus 6 minus 6, or you can do 6 divided by 6 times 6. Oh, wait, I already said that already. Yeah, you can also do 6 plus 6 minus 6, but yeah, there are many ways you can do this one. Okay, 7, 7, 7, and let's, okay, yeah, it's simple. Just do 7 divided by 7, that's equal to 1. 7 minus 1, that's equal to 6. Or now, 888, I'll skip for now. 999, just, yes, square each of them, and now you have 3, 3, 3. Just do what you did for the 3, 3, 3, 1. Do 3 times 3 minus 3. So square root of 9, that's equal to 3. 3 times 3, that's 9. 9 minus 3, that's 6. Now, let's go through the tricky ones, like 1, 1, 1. Can you make 6 with 3 1s? Yeah, many of you probably struggled with this one, but let me tell you how to do this. 1 plus 1 plus 1, that's equal to 3, right? Now the 3, and then just add a factorial. Just put the 3 in parentheses, then add a factorial sign. 3 factorial, 3 times 2 times 1, that's equal to 6. 6, so yeah, this is how you do the 1. Now, the 0 one, yeah, you're probably thinking, this one is impossible. Like, yeah, many of you probably think this one's impossible, but no, it's very possible. You could just do something for this one, like 0 factorial, that's equal to 1. I'm not sure if you know this. Like, some of you don't know this. 0 factorial is equal to 1. 1. So just do something as you did for 1, 1, 1. Okay, so 0 factorial. 0 factorial, that's 1. 1 plus 1 plus 1, that's 3. Factorial, that's equal to 6. Now, the hardest one is the 8. Yeah, you're 8. So if you manage to get the 8 one, congratulations. However, if you haven't, yeah, don't worry. Let me show you the answer. So 8 plus 8, that's 16. Square root that, you get 4. 4. For now, the 4 factorial, that's 4 times 3 times 2 times 1, that's 24. Divide by 8, you get 3. Now, 3 factorial, it's equal to 6. There you go. So how many of you were able to get all this? How many post in the comments below on how many you were able to get? Now, the next puzzle. Yeah, maybe you probably already heard of this puzzle, but let me show it to you anyway. Okay, so this is a puzzle where you're gonna try to connect all 9 dots with only 4 straight lines, and yeah, you have to draw all 4 straight lines in one stroke. For example, like you cannot simply just do it with 3 lines. I told you, you have to do it in one stroke, 4 straight lines in one stroke. So this one, yeah, so it might be a little tricky because you're usually gonna end up with 1 or 2 dots if you don't know the answer. So, like, yeah. Alright, so if you already know the answer to this puzzle, you can continue watching. If you don't, pause it and try to do it. And I'll give you a solution, later. You think you know it? No? Are you stumped? Okay, so I'll tell you what the answer is. You have to think outside the box, literally, like think outside the box. Like just first draw this line and then draw the line diagonally. Notice I went outside the box and then went this way, and then draw a horizontal line like this, and then draw a line diagonally. Remember, I never said you have to stay inside the box. Because the only thing I said was use 4 straight lines to connect all 9 dots, and see this is how you do it. So let's go to the last puzzle. This puzzle is called Euler's Trail. What you need to do is try to pass through each segment once and only once. Like let me just tell you what this segment is. Like this part, it counts as a segment because this vertical line divides this segment into 2 separate segments. Like this thing over here, this is considered a segment. This to here is considered a segment. This to here is considered a segment, and this part to this part is considered one segment. So what you need to do is draw a line that's not necessarily straight. Draw a line that passes through every segment once and only once. And don't pass the corners, and don't go along any lines. Like don't draw a line that goes along any of the segments. See if you can do it. Let me try doing it real quick. So I'm gonna try going through here and then go here, and then go this way and then this way. Yeah, I'm just gonna go this way and then here. Okay, then I'm gonna go here. Yeah, okay, I almost got it. I just missed this segment here. Okay, why don't you try doing this puzzle now, and I'll tell you the answer later. Many of you are probably thinking this is the easiest puzzle you've given me. But let me tell you something a little strange. Yeah, I hope you didn't waste your time on this because this puzzle is actually impossible. It's literally impossible. There is no solution to this. And if you want me to prove it, I'll prove to you that there is no solution. So, let me redraw the Euler's trail. Okay, here we go. So, let me give some segments of places you would have to go, like here. Here, give me a few minutes. Let me just draw this. I just need to sketch this real quick. Okay, these points will represent all the places you have to go. Like you will have to go inside each of these boxes at least once and go to these spaces exactly once. Like when you go here, then you pass out through this segment, or if you start from the outside and go inside. And now let me connect the dots together. Okay, I connected the dots together. Now let me tell you. For each box, every time you enter, you have to leave. So there has to be an even number because enter, you leave, you just made two paths. So there must be an even number. However, there are two exceptions. One of them is if you start at that box, which in that case there can be an even number of paths. And the other section is where is if you end at that point. Which at that point there can also be an odd number of paths. Like I'm not sure if you understand what I just said. Like you enter or leave, that's two paths. And notice that there are five. So this box you have to either start or end in this box. This box you also need to either start or end in this box, since you have to like get into this box five times. And if you don't start in this box, you will, or end in this box, you will. If you don't start or end in this box, you will have to go through this box for an even number of times, since you every time you enter you leave. So this one has an odd number of paths. This one also has an odd number of paths, and this one also has an odd number of paths. So that means if it has an odd number of paths, it's near a starting point or end point. But however, like there can only be at most two boxes that have an even number of paths, because there's only one starting point and one end point, which means there's only two boxes with an odd number of endpoints. And notice that there are three, so thus this puzzle is impossible. So, I hope I got you on that one. And again, I hope you didn't waste your time. So if you enjoyed this, please comment, like, or subscribe for more videos. If there's anything you would like to see in the next episode of Math Magic, please tell me in the comments below. And have a great day.